Hello, in the previous video, I've already shown you the half-wave rectifier, which consists of just one single diode. It's a very simple solution. This diode just very simply, very brutally removed all the negative half cycles. But that means that our resistor is connected to the AC power supply only half the time. So we are sacrificing half the power made available to us by the AC power supply. So is there such a thing as a full-wave rectifier? You're looking at one now. A full-wave rectifier consists of 1, 2, 3, 4 diodes connected in a very cunning way across our resistor. Let's figure out how it works. We start with the positive half cycles when this is a positive terminal and this the negative terminal. So the AC power supply is trying to push current this way, top to bottom. Let's consider this branch here. So if we are trying to push current this way, that will put this diode in reverse bias and this diode in forward bias. So reverse bias is an open circuit, forward bias is a short circuit. What about this branch? We are trying to push current this way, yeah? That puts this diode in forward bias and this diode in reverse bias. So forward bias is short circuit, reverse bias is open circuit. Can a current flow through the resistor? Yes, it does. It flows through it this way. So during the positive half cycles, the resistor is connected to the AC power supply. So the PD across it is also like this. Now what about during the negative half cycles, when this is the positive terminal and this is the negative terminal? So now we are trying to push current this way, which means this diode is in reverse bias and this diode is in forward bias. So reverse bias, open circuit, forward bias is short circuit. What about this branch? So this guy is in forward bias, this guy is in reverse bias. So forward bias is short circuit, reverse bias is open circuit. Can a current flow through the resistor? Yes. This time it will flow this way. So even during the negative half cycles, the resistor is connected to the AC power supply and the PD across it looks like this. So we have done it. We have managed to rectify an AC voltage fully. During the positive half cycles, the current flows this way. During the negative half cycles, the current flows this way. Now notice the current is always flowing in the same direction through the resistor. Yeah? So during the positive half cycles, the current goes this way, right? So this end is at a higher potential than this end. During the negative half cycle, the current flows this way. See, again, the current is flowing from right to left. So the AC power supply may be switching polarities all the time, but as far as the resistor is concerned, the polarity is always here, higher potential than here. That's very satisfying, isn't it? Alright, ta-ta!